Progress.
Good morning, everyone. Please confirm in the chat box. Is my voice audible? Yeah, perfect. So guys, we are going to develop one application by using one-to-one relationship. Let me create one Spring Starter project. JPA one-to-one relationship application. Already I have given the Git repository for that application as well. So let us see how we are going to create this project. I'm taking Spring Boot application with Maven dependency and Java 17. Here, dependencies. So we are going to work with database. So Spring Data JPA. Spring Data JPA I'm selecting, and I'm going to communicate with MySQL database. So let me take MySQL driver here. Good. Click on next and finish. So with this, our project is getting created. This project, we are going to communicate with MySQL database, and let's configure the MySQL database properties here. Let's configure database properties here. If you go to the Git repositories, so that one-to-one example is available. Spring Boot JPA one-to-one example is there. So go to SRC, then go to resources, where our database configuration is available in the form of YML. Okay, so let me take this YML properties. So go to our project. Let us change this properties file to YML file. From application and properties, I'm converting this to YML. Inside this YML, we are going to configure data source properties with which database it has to connect. So meanwhile, let us check what are the databases available in our system. Show databases. Show databases available. What are the databases are there? So let me find the database, or else let me create one database. Create database SBMS36. Okay. Then use this database. Use this database. Select a star from SBMS36 database. So currently there are no tables available. So let me configure this database name. I'm going to connect with this SBMS36 database. Now, in our application, let us create entity classes. Okay. So I'm going to take entity, person and passport, something like this. Now, in .ashokit.entity, I'm taking class name, I'm taking as person. Class name I'm taking as person. Now, inside the person class, let us store some variables. Let us declare some variables in the person class. So private string, private integer, I'm taking person ID, private string person name, and private date person date of birth, and private string person gender, something like this. So these are the variables I'm taking inside our person class. Okay, java.util date I'm taking. Next one, let us take one more entity class, which is called as passport entity. So I'm taking passport entity. So here, let us take passport number, passport ID basically, private integer passport ID, private integer passport ID, private string passport number. Passport number is a alphanumeric data. That's why I'm taking it as a string. Private date, issued date, when this passport is provided for the person, and when that passport is going to expire. So like this, we are taking issued date and expiry date in the passport. Now, person is one entity class. Let me represent this as an entity by using @ entity annotation. Passport is another entity class. I'm using @entity annotation for this one. Now here person ID. So let me take it as @ID and generated value. Generated value. We are going to specify strategy as identity. Specify the strategy as identity. Same thing is applicable for passport also. But now there are two entities available. One is person entity and the second one is passport entity. But is there any relation between the person entity and passport entity, or there is no relation between person entity and passport entity, guys? Currently, is there any relation between person entity and passport entity, or there is no relation between person entity and passport entity? Any relation is available, or there is no relation is available? There is no relation available between person table and passport table. Now we need to establish the relationship between person table and passport table. That relation also I want to establish as one-to-one relation. I want to establish that relation as one-to-one relation. So let us see how we are going to set up that one-to-one relation. Now, so here person is having passport. Passport belongs to person. Now you can declare one variable here, private passport. So in the person table, in the person entity, I'm writing the reference for the passport. In the passport entity, I'm writing the reference for person. So one entity class having the reference of another entity class. One entity class is having the reference of the another entity class. Here, person is having the reference of the passport. Passport is having the reference of the person. What is the relationship between the person and passport? What is the relationship between the person and passport? So here you can specify the relation as one-to-one relation. Here you can specify the relation as one-to-one relation with the passport. Now, if you go to passport, here passport is also having one-to-one relation with the person. Passport is also having one-to-one relationship with the person. Are you guys able to understand how we are representing this relation now? One-to-one relation. Now, person passport is belongs to person. Person is having passport. Now, I will consider person as a parent, passport as a child. Okay. So I'm going to you can consider anything as a parent, anything as a child, because here we are having only two entities, one entity having relationship with another entity. So this is my person table and this is my passport table. This is my person table and this is my passport table. Okay. So I'm going to consider person is a parent, passport is a child. So in the child table, I want to store the foreign key. In the child table, I want to store the foreign key. In order to store the foreign key in the child table, we are going to use join column annotation. What is the meaning of that join column annotation? It is used to represent what is the foreign key. It is used to represent what is the foreign key. So in the passport entity, I'm going to specify annotation called join column name is equal to person underscore ID. So it is going to represent this one. This passport table will have person ID as a foreign key. So that means if you see in this diagram here, person ID will be available. Person ID will be available, which we are going to consider as a primary key here. That primary key will be available as a foreign key in the passport table. So now person record we are going to consider as a parent record. Passport table will have person ID as a foreign key. Like this we are going to represent the relation. Here it is for primary key. Here it is foreign key. Here it is primary key. Here it is foreign key. Are you guys clear with my point? Are you guys clear with this point? Person table and passport table is available. Person having passport. Person I'm considering as a parent. Passport I'm considering as a child. So in the passport table, I want to maintain person ID as a foreign key. So to represent person ID as a foreign key, we are using join column. One-to-one relationship with the person ID as a foreign key. When you go to person table, one-to-one relationship is available and it is mapped by person. What is the variable name we have given? Mapped by person. Cascade type I am going to specify cascade type dot all. Whatever the operation you perform on the parent record, all the operations should reflect on the child record also. That's why I'm specifying cascading option here. Mapped by person, that means this passport record is mapped by person record here. Whatever the variable name you write here, that variable name you need to specify. It is representing person having a passport. Passport is mapped to person. So this is the entity class we are going to write. Let us generate setters and getters for this one. For these variables, I'm writing setters and getters. For these variables also, I'm going to write setters and getters. With this, our entity classes are ready with the relationships. Our entity classes are ready with the relationships. Are you able to understand how we are writing the relationship now? Person having passport. What is the relation between the person and passport? Person is related with the passport, one-to-one relation. One person is having one passport. If you go to the passport is belongs to person, one-to-one relation. Foreign key is required to represent the relation. In the passport table, I'm storing person ID as a foreign key. Join column is used to represent foreign key. So once entities are available, let us create the repositories. Now, so in.ashoka.repo, we are going to specify person repo, which is used to store the person record. So person repo is available. Extend the properties from JPA repository. Entity class is person and primary key is integer. Okay. Similarly, let us create one more entity, new class, which is passport repo. Let us extend the properties from JPA repository. It should be interface. Extends the properties from JPA repository. Here, the entity is passport. The ID is integer. That's it. So two entities are ready and two repositories also ready. Next one, let us create one service class to perform these operations, guys. I'm taking a service, person service. I'm taking a service called person service. I want to insert the record into the table. First, let us represent this class as a service. For that, we are using @service annotation. I'm using @service annotation. Then let me write dependencies, private, person repository, injecting the person repository into service using auto wiring. Then similarly, we are going to inject private passport repository and inject. Let us go for this auto wiring. Person repository and passport repository is available. Let us write the method to save the data. Public void save person with the passport. I want to save the person data along with the passport data. So let us create person object first. Person P is equal to new person. Let us set the data now. Person dot set ID will be generated, auto generated. Person dot set name. I'm setting the person name. I'm setting the person name. Then person dot set gender, some value. Person dot set DOB, which is a date. For example, new date. And person dot set gender, some value, something like this. Okay. So with this, our person data is ready. Then next one, passport data. Passport is equal to new passport. Passport is equal to new passport. Passport dot set passport number. Some alphanumeric value will be available for the passport, guys. I'm setting some random text. Then passport dot set issued date. So I'm giving some date object here. Then passport dot set expiry date, some new date object I'm passing. Okay. If you don't want to take the current date, then you need to change the type to local date. You can change the DOB also to local date, which is in the Java 8. Okay. Here data types are also going to change. Local date. In the passport also, you can change the date type to local date. Then whatever the date you want, that date you can set easily. I'm changing the data type to local date class. Then in the service, instead of this one, I'm going to specify local date dot now dot minus years, 20 years. Okay. So whatever the date of birth, with today's date 20 years back, we are going to get that date of birth. Issued date. Now I'm going to specify local date dot now. Today, the date that passport is issued. Passport will be there for next 10 years, guys. Local date dot now dot plus years 10. From today, the passport will be available for the next 10 years. So local date dot now minus 20 years for the date of birth. From the today's date, I am minusing 20 years. That will be the date of birth of the person. For the expiry date, with the today date, I'm adding plus 10 years. So today is the issue date, and next 10 years, after 10 years, it will be the expiry date for the passport. Now person record is created, passport record is created. Now here we need to associate. So that is association. What is the association? Person dot set passport and passport dot set person. This is called association. This person having which passport, this passport belongs to which person. Then save parent record. What is our parent record? Person. Person repository dot save of person. That's it. When you save the parent record, child record will be saved automatically. Now here I am having one person entity. That entity is having a relationship with the passport. That relationship is one-to-one relation. And passport is available. Passport is having one-to-one relationship with the person, and passport table will contain the foreign key column as person ID. Person table primary key will be stored as a foreign key in the passport table. Okay. And person repository available, passport repository is available. Inside the person service, I'm setting the data for the person and I'm setting the data for the passport, and I'm having association. Person record belongs to which passport? Passport record belongs to which person? I am associating these two records. Then I am saving my parent record. Inside the parent record, already passport data is available. Inside the passport, already person data is available. So when I save the person, then how it is going to insert the record. So here I'm using create option to show you every time the table will be recreated, we can understand how the data is getting inserted in the table. DDL auto, I'm giving as a create option. Are you able to understand how the association we are establishing between the person and passport? Guys, are you able to understand how the association is established between the person and passport? How the association is established between the person and passport. For the passport, I am setting the person. For the person, I am setting the passport, and I am trying to insert the record. I'm trying to insert the record. Okay. Can we test this method functionality? Can we test this method functionality? Local date dot now minus 20 years. There is a predefined method to minus the date values. Here plus 10 years, here minus 20 years I'm taking. So date of birth I can't set today. If for the person today, date of birth means today they can't apply for the passport. So that's why I'm setting the date of birth, today's date minus 20 years. So 2024, it will go to 2004. Date of birth will come as 2004. Date of birth will come as 2004. Passport expiry date. Today it is issued. Next 10 years will be there for the passport. Now, so forget about what data we are setting. Here association, and how do we establish the association between the entities and how we are going to save the record. Am I saving both parent and child record? Am I saving both parent and child record, or I'm saving only parent record here? Am I saving only both parent and child records? I'm saving only parent record. I'm saving only parent record. I'm saving only parent record. Able to follow this? Yeah. Let us test this functionality. For passport repository, I'm not using because I'm not saving the child record. When I save the parent, automatically child should be saved. That is what cascade I have given. Cascade type means whenever we perform operation on the parent record, that should be reflected on the child record also. Cascade all the operations on the parent table should reflect on the child table also. So that's why I'm using cascade all. When I save the parent, my child record also should get saved in the database. Let's check it. Is it working or not? Now, so go here, get the context object, get the context object. Now, from this context object, get the service bean, context dot get bean of person service dot class. Context dot get bean of person service dot get class, then service dot save person. We are saving person record in the database table. Now you see the console, how the queries will be executed. Right click, run as Java application. Application is getting started. MySQL driver connecting with the MySQL database. Yes, you see existing tables are deleted. Passport table is created. Person table is created. Inside the passport table, the foreign key constraint is added. One record inserted into person table, another record inserted into passport table. So now select the database. Tables are available. Use SBMS36, show tables. In SBMS show tables. Okay. So there are two tables available. One is passport table, another one is person table. Now select a star from person. So person table is having person ID, person date of birth, gender, and the name is coming. Then go for select a star from passport. Now you see in the passport table, passport ID available, person ID also available, passport number, passport issue date, and passport expiry date is also available. Now, do we have foreign key in the person ID in the passport table as a foreign key? Yes. So that is relation. Parent record and child record. We are considering person as a parent and passport as a child. So that's why parent record foreign key we are storing in the child table. Parent record primary key we are storing as a foreign key in the child table. So I have inserted only person record. When I insert person record, it is inserting person plus passport. It is inserting person plus passport. DDL auto I am giving as update. The table is already available. It is not going to create the table. Look at this service. How the data is getting inserted into database table. How we are establishing the association before inserting the record. Person having passport. Passport is having person. And we are saving person. Person is a parent that is having a mapping with the passport. Now here you see person is having mapping with passport, mapped by person. So this passport is mapped with the person. That's why we are inserting the person. When we insert the person, passport is also inserted automatically. Now let us see what will happen if I retrieve person record. If I retrieve parent record, what is going to happen? So it is a one-to-one relationship. Guys, when I retrieve the person record, if I get the passport record also, any performance problem will be available. Any performance problem will be available. Performance problem will not be available. One parent will have only one child, right? If one parent is having 1,000 childs, then performance issue. But when one parent is having only one child, if I retrieve parent plus child, if I retrieve both parent record plus child record, is there any performance issue or there will not be any performance issue? There will not be any performance issue. Now see the behavior. I'm going to retrieve public void get person. Okay. Now public void get person. I'm going to write the logic like this. Person repo dot find by ID of 1. Just I'm checking. I'm retrieving and record. Now see the query, how it is going to find that query. Later you can print that data, that's fine. Just I want to see how the query is getting filed when I'm retrieving parent record. Service dot get person. So I'm trying to retrieve parent record. When I retrieve the parent record, let us see what is the behavior of this application. When I retrieve parent record, what is the behavior of this application? We need to observe, is it going to retrieve only parent record or it is going to retrieve parent record plus a child record also? Right click, run as, boot application, get the person. I'm trying to retrieve the person record. See the query, how it is executing. Now, select person ID, passport record, from person, left join with the passport based on the person ID. So that means whenever you retrieve the parent record, it is executing a query like this. That means it is preparing a join query. Select person ID, passport expiry date, passport issue date, passport number, person date of birth, person gender, person name from the person table, left join with the passport table where person ID is equal to given value. So when I retrieve parent record, it is retrieving parent and matched child also. By using left join, we are going to retrieve the data. So what is the meaning of left join in the SQL? What is the meaning of left join in the SQL? So parent record and matching records from the child. Now you see, this is left join. This is the left join. So from the table 1, we are retrieving the parent record and parent record we are retrieving. With the parent record, the matched child records only we are going to retrieve. This is called left join concept. When there is a one-to-one relationship, when you retrieve the parent record, it is retrieving parent along with a matched child record also. Parent plus matched child records also it is retrieving. Suppose if I retrieve only child, then what will happen? If I retrieve only child, then what is going to happen? Public void get passport. Based on the passport ID, I want to retrieve. Okay. For this, we will go and use passport repo dot find by ID with 1. I'm retrieving only child record. When I retrieve only parent, we understood parent plus child is coming by using left join concept. Now, if I retrieve only child table record, then what is the behavior? Let us use service dot get passport. Service dot get passport. Passport is a child record. In our mapping, passport is a child. I'm retrieving only child record. Then see what is going to happen. When we retrieve child record, what is happening? How the query is getting prepared? Just observe that. Yeah, this is the query when I'm retrieving child record. Okay. Now also it is using left join. Now also it is using left join to retrieve the record. Right. So whenever you retrieve parent record, child is also coming. When you retrieve the child, then parent is also coming because one parent is having one child. This is 1-to-1 relationship. This is 1-to-1 relationship. Are you guys clear? How the data is getting retrieved when you go for, how the data is getting retrieved when you go for 1-to-1 relationship. So 1-to-1 means when you retrieve the parent record, then the child record is also coming. When you retrieve the parent, then the child record is also coming. When we retrieve the parent record, then the child record is also getting retrieved. Are you able to understand this? Good. Now, let me delete one parent record and see what will happen. Public void delete person. Public void delete person. Person repo dot delete by ID. I'm deleting parent record. Now see the behavior. Service dot delete person based on the person ID. Service dot delete person based on the person ID. Okay, guys. Now let us run this application. Run as boot application. See the console, how the queries are getting executed. Now you see, when I delete the parent record, only parent is deleted, or first child is deleted, then the parent is deleted. Guys, when we go for deletion of the parent, only parent is deleted, child plus parent is deleted. Only parent is deleted, or child plus parent is deleted. Child plus parent is deleted. Child plus parent is deleted. Are you clear? Are you guys clear with this one? So what is our understanding when we go for 1-to-1 relationship? Okay, 1-to-1 relationship. 1-to-1 relationship. For this 1-to-1 relationship, the code is already I have given in the Git repository. When we insert parent, child is also getting inserted. When we retrieve parent, When we retrieve parent, child is also getting retrieved. When we retrieve child, when we retrieve child record, parent also getting retrieved. Parent also getting retrieved. When we delete parent, child plus parent getting deleted. These are our observations, guys. So when we do association mapping, when we do association mapping, we are going to work on parent and child records. When we do operation on the parent, then it will reflect on the child also. When we do operation on the parent, we will reflect on the child record. It will reflect on the child record also. When we insert parent, child also getting inserted. When we retrieve parent, child also getting retrieved by using left join concept. By using left join. Here also it is going to use left join concept. When we delete parent, first child is getting deleted, then the parent record is getting deleted. Are you guys clear with this point?
Yes, sir.
Are you guys clear with point? What are our observations when we go for one-to-one relationship? When we insert parent record, child is also getting inserted. When we retrieve the parent record, child also getting retrieved. When we retrieve the child, parent is coming by using left join. When we delete the parent, child plus parent is getting deleted. When we delete the parent, child plus parent records are also getting deleted. Okay, this is one-to-one relationship. Now, similarly, how do we work with one-to-many relationship? Okay, how do we work with one-to-many relationship? As we discussed, one employee can have multiple addresses. One employee can have multiple addresses. So how we are going to set up the entities for one-to-many relationship? I think you might have already gone through the Git repository. I think already we have gone through the Git repository. How do we set up the one-to-many relationship for our application? So there are n number of use cases available when we are going for one-to-many. One employee, multiple addresses. One author, multiple books. One employee, multiple addresses. One author, multiple books will be available. One batch, multiple students will be available. One college, multiple students will be available. One university, multiple colleges will be available. So n number of scenarios we can take when we are establishing one-to-many relationship. So when we are going for one-to-one, one parent with one child only, so at the retrieval time also no problem will be available. But when we go for one-to-many, we need to consider that performance also, because if one parent record is having one child, if you retrieve parent along with child along with the parent, there is no problem. But when you go for one-to-many, we need to consider that performance related stuff as well. If I retrieve one parent, if I am getting 1,000 childs, that's not good. Okay, so there you will see the real power of cascading operation. Cascading means whatever the operation you do on the parent, it will reflect on the child table. Based on the cascading and fetch type, we are going to do the operations in the one-to-many many relationship. Okay, so how do we set up that one-to-many relationship? See here, file new Spring Starter project, file new Spring Starter project, JPA one-to-many relationship we are going to set up. One-to-many relationship we are going to set up. Click on next, MySQL driver and data JPA I'm taking. Click on finish. Right. Now database properties, anyhow we are going to configure, which is there in the YML. Same YML file I can keep here in this project. Okay. Now, so in order to set up one-to-many relationship, in order to set up that one-to-many relationship, we need to create entities first. Okay. So let me take new class as entity package. I'm taking one class called employee and another class I'm taking as address. Employee and address classes are there. Inside the employee, we are going to take employee ID, private integer employee ID, private string employee name, private double employee salary. Employee ID, employee name, employee salary. This is our entity. Okay. So this one is our primary key and I want to auto generate the value. Generated value strategy is equal to identity generator. As I'm using MySQL database, I will go with identity generator. Am I using MySQL database? I'm going with identity generator. Perfect, guys. Now, so here employee class is available, which is having variables ID, name and salary variables are available. Next one, let us go and create the variables in the address also. I want to represent address also as one entity and address ID. This table will have its own primary key, private integer address ID, private string city will be available, private string state will be available, private string country will be available. This address ID is a primary key. And let us use generated value strategy we are using as identity. Strategy we are using as identity. So currently employee and address, these are two different entities. There is no relation between these two entities as of now. These are two different entities. There is no relation between these two entities as of now. So there is no mapping here. There is no mapping here. Now, what kind of relation we want to establish? One-to-many relationship. That means one employee can have multiple addresses. So multiple addresses, nothing but list of addresses we are going to take. Private list of addresses. When we see from the address side, multiple addresses belongs to single employee. Multiple addresses belongs to single employee. Private employee EMP. That's it. So if you see from address side, address belongs to one employee. One address or multiple addresses belongs to one employee. If you see from employee side, one employee can have list of addresses. One employee can have list of addresses. Are you able to follow this? Are you guys able to follow this? Okay. Employee can have multiple addresses. Multiple addresses we are representing by using list. Multiple addresses we are representing by using list. Address side, employee. Now, if you see from address side, addresses, multiple addresses belongs to one employee. So what is the relation we are going to set up? It is many to one relation. This is many to one relation. Multiple addresses belongs to single employee. In the address table, employee ID should be inserted, which I am going to use join column name is equal to employee ID. Employee record employee ID should be stored as a foreign key in the address table. It should be stored as a foreign key in the address table. Many to one relation. Then, if you go to employee side, how the relation will be represented from the employee side? If you see the relation from the employee side, this relation is one to many. The relation is one to many. In this one to many relationship, we are going to specify this address is mapped to EMP. So we need to specify mapped by. Mapped by is equal to EMP. In the address table, what is the variable name for the mapping? EMP is the mapping. Cascade. Cascade type is equal to all. Okay. Then ARPAN removal. ARPAN removal is equal to true. So if your child does not have a parent, then delete that child record. ARPAN removal is equal to true, that we are keeping. So if you see from employee side, address is having one to many relationship. One employee can have multiple addresses. Address is mapped to employee. Address is mapped to this EMP, and the address side, if you see, many to one relation available, and the join column we are taking as employee ID. So these are entities. These are the entities for one to many relationship. So employee having list of addresses with one to many relationship. Address is having many to one relationship with employee. And here, which is our parent table and which is our child table, guys? With this configuration, can you understand what is parent table and what is child table? With this configuration, can you understand what is parent table and what is the child? Employee is our parent, address is our child. So parent table primary key value we are storing as a foreign key in the child table. Address table will contain employee ID. Address table will contain employee ID. Okay. So entities are ready. Then we need to perform insert, retrieve, and delete operations. Today evening, 5:30 p.m. we have the class. In the 5:30 p.m. class, we will play with this one to many relationship tables by using insert, retrieve, and delete operations. Okay. So whenever I delete the parent, ARPAN removal means child records also should be deleted. That is the reason I'm keeping ARPAN removal is equal to 2. So without keeping this, we will see how it is going to work. In the today evening session, we will play with these employee address tables by using insert, retrieve, and delete operations. Are you guys able to follow this? So today evening we have class at 5:30 p.m. So in that 5:30 p.m. class, we are going to discuss how to perform one to many relationship operations on the tables. All good? Fine, guys. So with this, I'm stopping for today and we'll continue in the evening session. So from tomorrow morning 7:30 a.m. Java real-time project is getting started, and Spring Boot few, as discussed, a few topics are pending. We will continue at the evening 5:30 p.m. classes. We'll continue at the evening 5:30 p.m. classes. All right, guys. Good. Thank you. So we'll meet in the evening session. Before coming to today evening session, please do the practice of that one-to-one relationship and try to explore that one-to-many. One-to-many Git repository already I have shared with you. Today we are going to understand the details of that one-to-many relationship with the coding part. Thank you, guys. Have a great day. Anyone having any questions?
So yes, sir. Without having setters, you are setting the passport and
Anybody having any
person.
questions?
Hello. Hello.
Yeah, guys. Anyone having any question?
Yes, sir.
Yeah, you can ask your question.
Sir, without having setters, you are setting the passport and person instance, right?
No, sir. In the person and passport, setter methods are available. Setter methods are there for the variables. No?
Sir, can you please open it?
Yes.
Not here, sir. This one, service class.
Huh.
Here, person 35 line number 35 36.
Correct. So
And
for that, already setter methods are available, right? Set person, set passport, get passport. For all, this is a variable. For this variable, setter method and getter method is also created.
okay, sir.
Sir,
Yes.
if we are when we are saving a child and child parent is required, na sir, every time.
Yes, sir. Whenever you are inserting the parent along with the child, we are inserting. When you want to save only child, parent should be available. Without parent, you can't save the child, right? Because there is a foreign key relation.
For parent also child required, na sir, every time.
When you are saving the parent, child is optional. But when you are saving the child, parent is mandate.
That variable taking null, sir, every time. And
Yes.
parent plus is.
You can insert only parent without child, but child cannot be inserted directly without parent.
Ashok, actually, we are using the relationship tag, right? So in one-to-many annotation, in that one, in parent type, mapped by, that means in one class we need to use that. In the same class, employee class, we are mapped with employee reference, right?
Yes, right. So now whenever you say one-to-many mapped by representing that, this address is how it is mapped to the employee. That is the meaning of mapped by. Address, how it is mapped to employee. In the address class, we have the EMP variable. Address is mapped to employee using this variable. So that mapped
That
by
variable we need, yes, that variable we need to mapped by this annotation in the parent class, right?
correct.
Okay. Yes. Thanks, Ashok.
Sir, can you please open the address class?
Yeah.
Sir, here 21st line number, name is equal to employee ID. Underscore is not there in the employee class, right? How it is
No.
mapping?
Whenever we create a variable with the naming convention, when the table is created, it will create the column with a name called underscore ID. If you see in our previous table also, person ID, for the person ID, underscore person ID is coming. In the person table, I have not given underscore. So this is the default thing in the JPA. When your variable name is available with camel case, here underscore will be added in the DB table. Table is dynamically created, right?
Yes, sir.
Yeah, so that's why whenever I keep here employee ID, when the table is created, it will create the column with employee underscore ID. That's why in the join column, I'm giving underscore ID. That is the column name. So this column name no need to be same, but it is recommended to be same.
Oh, okay, sir. Sir, without same means how it will map?
Just a name, now value will be stored. Column name can be anything. That's why people will use the same name. It's not mapping based on the name. It's mapping based on the value.
Oh, okay, sir.
Column value is important. But if you
Okay.
keep the same column name in the parent table and child table, that is having more readability. People can easily understand how one table is related to another table.
Oh, okay, sir. Thank you.
Yeah.
Sir, how to store multiple mobile numbers in one field?
If you want to store multiple mobile numbers in one field means you need to use either comma separated or you need to store as a different records. So whenever you have multiple mobile numbers, there should be some category. Work mobile number, home mobile number, personal mobile number, office mobile number, something like that. It's better to save in different tables. If you have only one table, comma separated, you need to store. But that's not recommended.
Sir, using collection also we can do mapping.
Collection, if you use, you can do that mapping. That means it will go to different table, right? Mobile numbers. Okay, good guys, thank you. We'll meet in the evening 5:30 session today.